Okay then, year 6, you should have had a go at that arithmetic test now, and the answers were on that second page. Now I just thought I'd go through a few questions that people might have struggled with, maybe a touch, just so in case you're not sure how the answer was, I'll tell you how to get to that answer. So I've got 8 questions that we'll have a go at. We'll have a look at number 5 first of all, which is 50 times by 4,000. Now you could have written this out in the formal long method with 4,000 and 50 underneath, but there would have been an awful lot of zeros in there, so a few opportunities for you to go wrong. But what you could have done here is just use your times tables knowledge, knowing what 5 times 4 is, knowing that that is 20. Now there was 1, 2, 3, 4 zeros taken off there, so you could add on 1, 2, 3, 4 zeros to get you to 200,000. Now you could have written it out 4,000 times by 50, which would have been absolutely fine. You should have got to that answer as well, but that method there is just far more efficient. So moving on to number 13 now. This is one of the questions that does trouble some people now and then. It's a mixed number fraction and it's a subtraction. Now remember, when you are adding or subtracting a fraction, the denominators need to be the same, and they're not here. So ignoring the whole number for now and just looking at the fractions, we need to make these denominators the same. Now a way of finding that would be multiplying these together to get to 40. However, there is a smaller one than that. 20 is the lowest common denominator, so we will use 20. So what do I have to times 4 by to turn it into 20? I have to times it by 5, so we need to do the same to the numerator to keep it as an equivalent fraction. So 3 times 5 is 15, and we know that that is 20, and now we can add in the whole numbers. So same with this fraction, I have to times 10 by 2, so I have to times 3 by 2, so then it is 6 over 20, and we can see now these fractions are the same denominator, so now we can go ahead and do this. Now because this fraction is larger than this fraction, we can actually just subtract the whole numbers, then subtract the fractions. So 7 take away 3 is 4, 15 take away 6 is 9 over 20. Now if you did make the denominator 40, 4 and 18 over 40 would be an acceptable answer as well, because they are equivalent fractions. This is just the answer in the simplest form. Right, so looking at number 14 now, it was dividing by 2 digits. Now you could have written out your 33 times tables down here, but it's probably not the most efficient way. Using the factor method would be more efficient for this. So which 2 numbers can you multiply together to get to 33? And hopefully you've realised that is 11 and 3. So first of all, if we divide by 3, and then we will divide our answer by 11. So how many times does 3 go into 6? Twice. How many times does 3 go into 2? It doesn't. Carry the 2 over. How many times does 3 go into 27? It's 9. And then the 209 now comes down here. How many times does 11 go into 2? It doesn't. Carry it over. How many times does 11 go into 20? Once, with 9 left. How many times does 11 go into 99? 9 times, so 19 is your answer. That method is definitely far more efficient. If you did it right now, your 33 times tables, you would have had to do it 9 times. So that method is definitely more efficient. So looking at number 15, 625 divided by 25. And you could write out your 25 times tables here, because 25 is one that's quite easy to calculate. However, let's go factor method again and doing 5 and 5, because 5 times 5 is 25. How many times does 5 go into 6? Once, 1 left. How many times does 5 go into 12? Twice, with 2 left. How many times does 5 go into 25? 5 times. And then we divide 125 by the other factor, 5. How many times does 5 go into 1? It doesn't. 5 into 12 twice, 2 left. 5 into 25 is 5. So the answer to that one is 25. Right, a few more questions I'd like us to have a look at. So number 17 was 56.5 times by 6. Now I've written it out in the formal column method. Now the important thing is this decimal place, remembering that the decimal place has to be lined up. Now you could have done it now at the start, you could have done it as you were solving it, or you could have done it at the end. As long as that decimal point gets lined up, remember the golden rule of decimals, lining it up. As long as it gets lined up, you should always get to the same answer. And now we can just approach this like a normal multiplication. So 6 times by 5 is 30, so the 0 goes there, the 3 gets carried over. 6 times by 6 is 36, add the 3 is 39. 6 times by 5, we've already said that is 30, add the 3, 33. So the answer is actually 339. If you wrote 339.0, that's fine as well, because that's identical. 339.0 is the same as 339. So another decimal question, number 20. This question was actually 12 subtract 1.3. All I've done is put 12.0, because remembering, just like how this is still 339.0, it's the same as 339. 12.0 is the same as 12, isn't it? It's just saying that there's nothing after the decimal point. But in this case, it makes it easy because we can line up those decimals, golden rule of decimals. So our answer is also going to have a decimal in. And now we can just approach it like a normal decimal, like a normal subtraction. 0 take away 3, we can't do that, so we have to exchange from the 2 becomes 1, and this has come now over to make this 10. So 10 take away 3 is 7, 1 take away 1 is 0, 1 take away 0 is 1. 10.7 is your answer. You could have possibly done it in your head by counting along on a number line, but we've double checked and made sure there. Right, now 23 and 27 are questions that we're actually doing this week. The only thing that might have confused people was this, the fact that it's 50% times 45. Now we talked about this briefly earlier on when we did fractions. It's the same as of, this is the same as 50% of 45, so it's like the same as half of 45. 50% times 45 is asking you what is 50% of 45. So remembering that 50% is the same as a half, there are two 50s in 100% is out of 100, so a way we can work this out is dividing it by 2, splitting 45 in 2, splitting it in half. So how many times does 2 go into 4? Twice. How many times does 2 go into 5? Twice. With 1 left, we can create a decimal now by adding that 0 in. How many times does 2 go into 10? It's 5. So 50% of 45 is 22.5, or 50% times 45 is 22.5. Right, finally look at number 27. Again, it's something we did this week. 10% of 387. Remembering that 10% is, the calculation we do is the same as dividing it by 10. So again, if we were to write a very straightforward place value chart in here, 387, the hundreds, the tens, the ones, and the tenths. Same as dividing it by 10, so everything gets moved over once to the right. So the 7 will come here, then the 8, then the 3, decimal point in the same place, so 38.7. Right, so hopefully that has cleared up any of those that you might have struggled with. So that is the end of the maths for this week. We'll have some more for you on Monday. So I hope you enjoy your week in Year 6. Take care.